All right, guys, need your note sheet from Friday. Yeah. Let's see here. Yes, we did this one on Friday. All right, guys, so we're continuing the note sheet from Friday. So we did one multiplication problem. We're going to do a second one here. So let f of x be x cubed and let g of x be the square root of x. We want to find f times g of x. The domain for this is going to be all real numbers greater than 0, greater than or equal to 0. Then evaluate the product when x is equal to 4. So our f times g of x is really just telling us that we have f of x times g of x. We're multiplying the two together. And at this point here, we can replace f of x and g of x with their corresponding functions. Now, since they told us f of x is x cubed, we'll replace f of x with our x to the third power. And since g of x is the square root of x, we're going to replace it with the square root of x. Now in 5.5, we will go over especially how to rewrite radicals in exponential form. But at this point, I'm not worried about it. I'm not concerned about it. So when we multiply, we're just going to say that it's x cubed times square root of x, which it is. If we wanted to rewrite it as a single variable, we would have to change the square root of x to exponential form. But f times g of x is x cubed times square root of x. Questions on how we got to this point here? Questions? Questions, Braxton?
Actually, I have a question.
Okay.
Is this like going into or after spring break also?
Well, we'll talk about chapter 5 after spring break, but it won't be a part of the test.
Okay. We have a test? Definitely after.
No.
Hey, leave her alone.
All right, guys, focus on. So then it asks us to evaluate when x is 4. So we're going to replace every x in our f times g of x with 4. So we'd have 4 cubed times the square root of 4. Now we can do this in a calculator. We can say 4 cubed, second square root, not 7, 4, is going to be 128. Because 4 cubed is 64, square root of 4 is 2. So when we evaluate it for 4, we get 128. Questions on those here? You ready for the next one? Okay. $64. Square root of 4. That's 2. Yeah. Multiply them together. Now the next one we have is dividing, f divided by g of x. And our f divided by g of x is really f of x divided by g of x. We're going to divide the two. And the domain would be any values of x that work in both of them. So x to the 3/4 is technically going to be a radical, so x would have to be greater than or equal to 0. But because g of x is on bottom, it has to be greater than 0. Now, at this point here, we can replace f of x and g of x with their expressions. So f of x is going to be 6x over g of x, which is x to the 3/4, which is really telling us we just have 6x over x to the 3/4. Now at this point here, we can simplify, because when we have like bases being divided, the x on top and the x on bottom, we subtract the exponents. Now, even though it's a fraction, it still works the exact same way. Now, the exponent on top is 1. The exponent on bottom is 3/4. So 1 minus 3/4 is 1/4. Is it bigger? Is the exponent bigger on top or on bottom? On top, because 1 is going to be bigger than 3/4. So it's going to stay on top. And since there's nothing left on bottom, it's going to be 6x to the 1/4. Questions on how we found f divided by g of x as 6x to the 1/4. Now the other piece that it wanted us to find is when, evaluate this when x is 16. So here we have 6 times 16 to the 1/4. 16 to the 1/4, we're really trying to figure out what times itself 4 times is 16. Or we can let the calculator do it for us. Because 2 to the 4th is 16, so the 4th root of 16, or 16 to the 1/4 power is 2, and 6 times 2 is 12. Questions on this here? Questions on any of this so far? We're ready for the next one. Okay. F of x is 4x, g of x is x to the 2/3. We want to find f divided by g of x, and then evaluate what x is 27. Interestingly enough here, the domain is going to be all real numbers except 0. The only value x cannot be is 0. Now for us here, f of x is 4x. G of x is x to the 2/3. And like the last one, we could put parentheses around the top and bottom, but all we're going to do is drop them. Now again, we need to simplify. Since we don't have a radical on bottom, we can actually do our dividing like bases. Because the numerator is x to the 1st, the denominator is x to the 2/3. So when we divide like bases, we subtract those exponents. So 1 minus 2/3 is 1/3. Now since it's bigger on top, that variable is going to stay on top. It's going to stay in the numerator, giving us 4x to the 1/3. Questions on how we found f divided by g of x? Now, when we evaluate when x is 27, let's focus up here. We're just replacing x with 27. So we're wanting to find 4 times 27 to the 1/3. So 1/3 power is really saying what times itself 3 times is 27. And that would be 3. So this is actually also going to be 12. So this is 27 to the questions on this here. And if we'd been multiplying these here, we would add the exponents. When we multiply like bases, we add the exponents. When we divide, we subtract. Any questions on anything so far? So, we're going to look at it again. We'll do some more addition, subtraction, more multiplication, division to round this out. So let f of x be negative 2x to the 2/3 and g of x be 7x to the 2/3. Find f plus g of x and f minus g of x, and then evaluate both of them when x is 8. Now f plus g of x is really just saying f of x plus g of x. F of x is negative 2x to the 2/3, and g of x is 7x to the 2/3. So we're just replacing f of x and g of x with their corresponding expressions, what they're equal to. And because we're adding, we can just drop the parentheses. Telling us that we have negative 2x to the 2/3 plus 7x to the 2/3. Now, because both of the variables are put to the same exponent, they are considered the same. So these are both like terms. So we can go on and just add the coefficients. Negative 2 plus 7 would be 5x to the 2/3. So our f plus g of x would be 5x to the 2/3. We can go on and subtract. Our f minus g of x, which is just another way to say f of x minus g of x. And we'll do the same thing, negative 2x to the 2/3 minus 7x to the 2/3. Now at this point here, we can drop the parentheses. Our negative 2x to the 2/3 stays the same, but because we're subtracting, we apply that negative to the 7. It goes from positive 7x to the 2/3 to negative. So we're saying negative 2x to the 2/3 minus 7x to the 2/3. Negative 2 minus 7 would be negative 9. Telling us our f minus g of x is negative 9x to the 2/3. So we get these two answers here. Questions on how we got the plus, the addition, or the subtraction answers, or some are different? Yes. Now the other piece that they wanted us to evaluate this when x is 8. So now we just need to plug 8 in for x. And for our sum, we'd have 5 times 8 to the 2/3. And to find this value, again, I would grab the calculator, say 5 parentheses 8 to the 2/3 is 20. Because 8 to the 2/3, it's really taking the cubed root of 8, which is 2, squaring it, giving us 4, and then multiplying it by 5. But the calculator can do that perfectly fine. We also need to do this with our subtraction. So we need to figure out what negative 9 times 8 to the 2/3 is. So we can say negative 9, parentheses 8 to the 2/3. And it tells us it is negative 36. So we actually had 4 answers for this, and this is going to be exactly like the homework. So we have f plus g of x is 5x to the 2/3. We evaluated it for 8, it is 20. F minus g of x is negative 9x to the 2/3. And when we evaluated it at 8, we got negative 36. Questions on those here? F times g of x, which is just f of x times g of x. And f of x for us is 3x. And g of x is x to the 1/5. So we wrote it out as f of x times g of x. We replaced f of x with 3x. We replaced g of x with x to the 1/5. Now we want to multiply these together. Now we're going to multiply the numbers in front of our variables first, which is just going to be 3 times 1, which is 3. And we'd also want to multiply the variables, x times x to the 1/5. When we multiply like bases, we add the exponents. So here we have 1 plus 1/5, which is 6/5. Now, since they gave it to us in exponential form, not radical form, we're going to go on and simplify. We're not going to write it as x times x to the 1/5. We want to combine those like terms. Those are multiplied like terms. Yes. So when we multiply like bases, we have to add the exponents. So we're doing 1 plus 1/5. Because we multiply them 6 times 3. Because when you multiply like bases, we add the exponents. You're adding those exponents together. Because we have x to the first times x to the 1/5. They are like bases. We add those exponents together. So here we have 1 and 1/5. So 1 for the first, 1/5 for the second. So since we're multiplying those like bases together, we're saying that we have x to the 1 plus 1/5. And 1 plus 1/5 is 6/5. Whenever you multiply like bases, you have to add the exponents. And for the most part, we're used to adding integer numbers, 2 plus 3, 7 plus 5, not so much these fractional exponents, but they work the exact same way. Now we'll also look at the other, our f divided by g of x, which is f of x divided by g of x. And f of x for us is still 3x. G of x is x to the 1/5. Just like the previous problems, since we don't have radicals, it's not written in radical form, we do need to combine these terms because our x to the first on top divided by our x to the 1/5. When we divide like bases, we're going to subtract those exponents. So we have 1 minus 1/5, which is 4/5. Now, according to our properties of exponents, we would always move it to the top. And then if it's negative, we move it back to the bottom. But here, it was bigger on top, so it's going to stay on top. And our x to the first divided by x to the 1/5 would be x to the 1 minus 1/5. 1 minus 1/5 is 4/5. Telling us that we have 3x to the 4/5. And the last thing it wanted us to do is to evaluate it when x is 32. So we have 3 times 32 to the 6/5. 3 times 32 to the 6/5 is 192. Now we also need to do this for our division. 3 times 32 to the 4/5. And again, just like with our multiplication, we can plug it in. 3 times 32 to the 4/5 is 48. Questions on these here? Questions on any of these here so far? Okay. You don't have to write this one down, but I do want to show you if we ended up, it didn't ask us to divide this. So if we did f of x divided by g of x for this one here, because the denominator is going to be a radical square root, you can leave it as this here. You don't have to convert it, because if we wanted to simplify this, we would have to either multiply the top and bottom by square root of x to rationalize the denominator, or turn it into an exponential form. But I'm not too concerned with that at this point. This will work. It is not simplified. We normally can't leave it in that form, but I will take it in that form for this one here, for this assignment. All right. You want to grab a crafting calculator if you don't already have one. Yes. Yes. Mm-hmm. Yes. Because cubing 27 is going to be quite large. Because it's going to be 6 times negative 27 to the third. So, all right. So, first thing you want to do is turn that graphing calculator on. Once you get it turned on, hit y equals. Clear all that out. So we want to clear everything out. So y equals, we want all that cleared. And what we're going to do is we're going to type the two equations that they gave us in. F of x is told to us to be the square root of x. So in the first equation, we're going to go second square root and put in x. The second equation, or g of x, x. So the square root of x. If the batteries are dead, I'll take that. Thank you. Now the other equation, they told us g of x is the square root of 9 minus x squared. Is everybody able to get both of those equations typed in? Okay. So we have both of them in there. Now, the problem asked us to evaluate f plus g of x when x is 2. So what we're wanting to do is find f of 2 plus g of 2. Now there's two different ways we can do this in the calculator. One of them is going second graph, so we pull the table up and add the two y values that they gave us. Because when x is 2, our first one, f of x, is going to be 1.4142, and g of x is going to be 2.2361. We can get a second calculator, add those together, and have it do that there. Second quit. We want to go back to the home screen. Alpha trace. Alpha F4. Now you should see Y1 through Y0 pull up this menu, yes? Now the first function that we typed it in was in Y1. So we want to hit enter. And you should have Y1 there. Yes? So we get an alpha trace and then selected Y1. Now the number we're typing in is 2. So we want to put parentheses 2, close parentheses. Because what we're told the calculator so far is that we want to take the function in Y1 and plug 2 in for x, or plug 2 into that function. But we want to add to it, what? Alpha trace Y2. So we're telling it to take Y1, plug 2 into it, then take Y2 and plug 2 into it, and add those two values together. We're able to get this typed in. Hit enter. So I took those two equations and evaluated both of them when x is 2, and added that together. So it actually found f plus g of 2. So 3.65. Now, if we want to find f minus g of 2, we're going to do the exact same thing. So we're going to grab the calculator. We're going to go alpha trace y1 minus alpha trace y2, and have the exact same equation. Thank you. And how to do y1 minus y2. Questions on how we type this in? Able to get it typed in? So, parentheses, 2, close parentheses, minus alpha trace y2, and then parentheses 2, close parentheses. Enter. You're welcome. So negative 0.82. Now it also wanted it for f times g of x, or f times g of 2. So we'd have f of 2 times g of 2. And again, we can go alpha trace y1 parentheses 2 close parentheses times alpha y2 and type the whole thing in. Now if you use the arrow keys and go up and highlight it and hit enter, it'll bring it back down. So we move up twice, select it, hit enter. We can pull it down, and the nice thing is I can go right over the top of the subtraction and change it from subtraction to multiplication, telling us that when we multiply these two together, we get 3.1622 or 3.16. And the last one it wants is dividing, which is f of 2 divided by g of 2. And we can do the exact same thing. We're going to y1, 2 divided by twice 2 of 2. And it'll tell us that it's 0.632 or 0.63. So the calculator can do these pretty quickly, and we don't have to actually plug in a whole lot of numbers. Questions on this here? I'm not going to ask y'all, you don't have to do those for the homework assignment, but I did want to show you so that you know how to do them. And that is it. You have the rest of the assignment to work on the 4 problems.